Physics of the Ear by Bailey Smith, Sam Mitchell, and Christina Odom. Structure of the ear. The ear is made of three different parts: the outer ear, the middle ear, the inner ear. Structure of the outer ear. The outer ear consists of the pinna and earlobe. Function of the outer ear. The outer ear functions to collect sound and funnel it to the eardrum. The pinna directs sound waves from the outside into the ear canal, which in turn channels sound waves to the eardrum, causing it to vibrate. The eardrum is a thin, semi-transparent, flexible membrane that separates the outer and middle ear. Structure of the middle ear. The middle ear contains the eardrum, three small bones called the malleus, incus, and stapes. Function of the middle ear. The eardrum sets into motion the first ear bone named malleus, which transmits the motion to the second bone named the incus. Finally, the third bone, named stapes, works like a piston to amplify and transform the sound energy into mechanical energy. This mechanical energy is then transmitted from the stapes to the cochlea of the inner ear via a thin membrane between the middle and inner ear called the oval window. The middle ear is connected to the back of the nose by the eustachian tube. Structure of the inner ear. The inner ear is made of two parts. The cochlea is a coiled structure that looks like the shell of a snail. Semicircular canals are three fluid-filled bony channels.
The process of hearing involves sound waves creating mechanical motions that cause fluid in the ear to move in waves and trigger nerve impulses that the brain interprets as sound. The outer ear functions to funnel sound waves. The vibrations from these waves reach the middle ear and move the tympanic membrane, also called the eardrum. This causes three bones, called the auditory ossicles, to also move. The bones make contact with a fluid-filled structure in the inner ear called the cochlea. The mechanical movements of the auditory ossicles move fluid inside the cochlea. Fluid waves move hair cells that line the cochlea. The movement of these cells activates nervous system receptors. Signals are carried through the vestibulocochlear nerve, cranial nerve 8, to the temporal lobe of the brain, where they're interpreted as sound.
Main functions of the ear. The two main functions of the ear are hearing and balance. Balance. The vestibular system is responsible for balance. Within the vestibular system, there are three parts to your inner ear that keep your balance, and they are connected to your cochlea. The balance system of your ear is connected to the cochlea and uses the same fluid. The three main parts that make up your vestibular system are the saccule, utricle, and semicircular canals. Balance in the saccule and utricle. The saccule and utricle are responsible for sending signals to the brain when you move up and down or forward and backward. The fluid inside your utricle pushes on the hair cells, which tell your brain that you are moving forward. When you drop down a steep hill, the fluid in your saccule moves. The fluid pushes on the hair cells in the saccule, which tell your brain that you are moving down. The fluid moving in this part of your ear tells your brain which way you are going. The fluid in your utricle and saccule moves different ways. Balance in the semicircular canals. The semicircular canals are three round canals that contain fluid. These are all in a special position so that no matter which way your head moves, some of the fluid in the canals move. When this fluid moves, it signals to your brain that your head is moving. If you nod your head yes, the fluid in your semicircular canals moves a different way. Hearing. The cochlea is part of the inner ear used to hear. It is filled with fluid, membranes, and cells. According to the physics classroom, the human ear serves as an outstanding transducer. converting sound energy to mechanical energy to a nerve impulse that is transmitted to the brain. The ear's ability to do this allows us to perceive the pitch of sounds by detection of the wave's frequency, the loudness of sound by detection of the wave's amplitude, and the timbre of the sound by the detection of the various frequencies that make up a complex sound wave.
Sound waves. Sound waves are caused by vibrating objects. The waves can pass quickly through solids,
a bit more slowly through liquids, and more slowly again through gases.
They can't travel through a vacuum. If a sound wave hits your ear and makes it vibrate, you hear the sound. Sound waves can be reflected by hard, flat surfaces and absorbed by soft ones. Reflected sound waves are echoes. They can also refract. The loudness of a sound depends on the amplitude of the wave, and the pitch depends on the frequency. High-frequency sound waves sound high-pitched, and vice versa. Human beings can only hear sound waves between about 20 Hz and 20 kHz.
Did you know your big toe isn't crucial for balance? To keep from being drafted into the Vietnam War, some young men cut off their big toe because the injury would make them unfit for duty in the government's eyes. But the big toe isn't crucial for balance. Wearing headphones for just an hour will increase the bacteria in your ear by 700 times. The roar that we hear when we place a seashell next to our ear is not the ocean, but rather the sound of blood surging through the veins in the ear. This is the most important takeaway that everyone has to remember.
Dude gonna fall when he get out. Oh, he start laughing real quick.
A little more. You ready?
Look at him. He can't get. Oh my God.